Hello. In this video, we'll learn to add two vectors. Here we're adding vector S1, and in polar coordinates, it's 12 meters, 29.2 degrees north of east. And we're adding it to S3, which is 8.5 meters, 22.3 degrees north of west. These are the same vectors which on page 1 of this handout you calculated the components of already. And we'll be using these components to solve for the components and ultimately vector r. So let's go ahead and draw the diagram. Well, it's already been partially drawn for us. You could see vectors S1 and S3 have been drawn and arranged head to tail on the page. Let's draw the resultant vector, the sum of these two vectors. There is vector r extending from the tail of the first vector to the head of the second vector. All right, to calculate r, let's add the components of all these vectors to the diagram. Here are the components of S1. This is S1 east, and this is S1 north. And this is S3 north and S3 east. Now let's draw the components of R. Here are the components of R. We have R north and R east. Perhaps you can see from this diagram now how it is that we're going to calculate R. We're going to find the components of R, the north and east components. Can you see that vector R north is equal to the sum of vectors S1 and S3, or the north components, I should say. We can write R north is equal to the sum of let's do it like this. We could say that S1 north plus S3 north equals R north, right? We could write it like that. Or you could write it like this, as I have done in type here. Okay? And the same is true with the east components. The east component of R is equal to the sum of the east components of S3 and S1. Let's go ahead and use the values that we found previously to calculate this vector here. So S1 north equals 5.854 meters plus S3 north, which is 3.225 meters. And that's going to give us 9.079 meters. Okay. Let's do the same thing with the east components. Okay, we have S1 east. We're going to add to it S3 east, and that's going to give us R east. S1 east, that's 10.475 meters, and S3 east, negative 7.864 meters. We add those together, and we get 2.611 meters. Okay, now we have the components of R east and R north. And now, if we like, we can express the vector in polar coordinates. Let's do that. So we have east and north components. Let's just use the Pythagorean theorem, right? That is R squared, or the magnitude of R squared, equals the magnitude of the east component squared plus the magnitude of the north component squared. We could say that R equals the square root of the east component plus the north component. Okay, and we get R equals 9.45 meters. Okay, we need to find the direction also. We can use tangent for this purpose. Let's find this angle. So that angle, theta, equals tan to the minus 1 of the opposite side, R east, which is 2.61 meters, divided by the adjacent side, which is 9.079 meters. That gives 16.0 degrees. So we get R is 9.45 meters and 16.0 degrees east of north. Okay, I'm going to let you do the ones on the next page. You could probably fit these two on the handout. These ones you'll need to use a separate sheet of paper. You can find answers at the bottom. Look over here at the Solutions tab to find solutions for those, okay?